Yo, what's up? A little bit late today, gonna go 30 minutes more. Okay, so I want to close off Tessellation today, and I think there's a big chance we're gonna do it. We have this very beautiful topology right now, but we have one little tiny bit of error, and I'm talking about this one right here. We should have a line going like this. I'm pretty sure we didn't have this at one point yesterday, but I must have mistakenly reverted some change. So we're just gonna fix this one first. Then we're gonna see if we can put the tessellation into its own file, make it includable in our shaders. And we're also going to work a tiny bit with the interpolation of the points. By that I mean reduce the popping we can see here. I don't know how visible it is if we do this. Yeah, you can see it pops. We're gonna have to reduce the tessellation for this to actually be visible, but yeah, we're gonna fix that real quick. Yo, what's up, Tutu Apps? Long time no see. I'm doing fine, it's going good. How about you? Okay, so let's focus on the missing lines here. First of all, we don't do any distance yet, so let's change this one. We can change. Yo, good morning, Harukanan. Okay, so it's this one right here. We're just missing a little bit of a line here. This is gonna look beautiful, I think. Okay, anyway. So let's just figure out which triangle it is that gets screwed up. And we can do it by removing this. We still have it for this one, so it's not this one. We don't have it for this one, so it's this one, okay. So if we do the one starting with 01, we do 01, S1201. We create this new point if we need to. And that is S01, S0101, S0101. Then we add S01 again. So we do dot, dot, dot. And I think that's correct. Then we restart strip and we start at S1201, which we probably want to do. And then we want to go S1201, S01, S12, S1200. So what is... Is it really this one? Looks to be that one, all right. But okay, so when we go S1201, S01, S12, which we do. Or is it simply this one? $25, let's do 28. Pretty sure 24 is the new points we get. Let's see how many appends we do. 4, 8, 12, 16, 20, 24. What am I missing here? Oh, everything else looks so damn good. To jabs, maybe to make exact ground, hills and rocks and stuff like that, you could try 28. So the number we inputted is the maximum amount of vertices we return from the geometry shader, and it's literally capped currently at 24. Like, we don't... Worst case scenario, we add 24 vertices. I think it's just the order of how we do the triangle strip. I have no idea in what way we screw it up, or I screw it up. I take full responsibility. We do this one first, and then we do this one. Maybe we should start with this one. We walk here, and then we do this one. Ah, no. Should we go this one, this one, this one, this one? S12. But we don't want to change the order, but maybe. How would we go without a change? We would go this, this. Yeah, without it we went 01, S12, 01, S01. S12, S12, 0. Walking. Yeah, we're doing it in the wrong order, so we want to do S01. O1. I just don't want to screw it up when we don't have this if statement. I think we pretty much want to go like this, right? For this one, we start at this one. Should we start at this one here as well? If we go... It's a little bit different. Okay. We can do it like this. Just to make sure that this is where the problem lies. I mean, here. We do... this works, and then we have that last to take care of, and let's do it as S12O0. S12. S01. S12. S1201. And we have the last one. We continue here. Maybe. We're getting... Yeah, we can't. What we can do... Then we do 01. S01. Okay. S01. Fuck, if we do it like this, we want to go this way, yeah. Which makes me wonder if we can do this as one stripe. One sec. S01. S0101. S1201. And finally 01. Beautiful. But. So basically we go this one, this one, this one. But we have this one in the previous year. Yeah, we can't do that. I need to look into these. Yeah, what's up, Cooler SK? Yeah, I ran 30 minutes late today, unfortunately. I need to read up on triangle strips because I think... Pretty sure we can do some magic here. The lesser triangle strips, the better. The less triangle strips, the better. The less if statements as well. One can probably do some magic here where we fill up an array of some sort and loop through it. I don't know. Triangle strip. Yeah, this is easy. If we look at this one, having this one as one triangle strip. Yeah, as soon as we get a vertex with more connections than 3, it's my understanding that we're fucked. But yeah, that's probably true. Or more than 4, maybe. More than 4. 1, 2, 3, 4, 5. 5 is... But okay, we have 5 for that one. How many do we have for this one? This one only has 4. This one only has 4. This one we should definitely be able to do as 1. 100%, right? 1, 2, 3, 4. 1, 2, 3, 4. Okay. So the vertex or the triangle, yeah, is always created from the previous 2, and we want to make sure that it's clockwise as well. Previous 2, you say. Clockwise, damn. Bam. Bam. Duh, duh, duh. Dun, 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 dun. What the fuck? That should be it. I want to try this. So if we don't restart the strip here, and we go 01, and we go what did I say? Dum. Yeah, okay. If we want this topology, we won't be able to do it. And this becomes counterclockwise. But if we... Because if we go... This one, this one, this one, we have made sure that we're clockwise. If we take this one as the next, we create it from this, this, and this one being the last one. If we then move to this one, it's this, this, and this that creates the triangle, and it's wrong. But if we want to make sure we're clockwise, this, this, this. We can't go like that. This, counterclockwise. If we start with this one. Oh, start with this one, no. Gotta start with this one, and then this one, and this one, then this one, but then we create it from this. Fuck. Yeah, it's probably the topology constraints we have that screws it up. Probably, unless you find a very creative way to do it. I want to double check. Do we have anything in triangle stream? Triangle stream. Append and restart strip. That's pretty much it. Okay. If we were to be okay with counterclockwise then, so we go this one, this one, this one. and this one, and this one, and this one. If we went counterclock, dum 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 dum. So if we go dum dum counterclockwise, fuck, can we define that? It would be amazing if we could define it. Yo, what's up, Yannick? Why it needs to be clockwise instead of counterclockwise? Let's make a quick drawing. Because it creates the normal based on the winding order, I think the correct term is. So pretty much when we create this triangle like this and we go clockwise, our normal is going to be located pointing outwards from the triangle. If we do counterclockwise, the normal is going to point in the other direction, and it's going to be culled depending on our shader. So if we have a shader that culls backsides, we're not going to render this this triangle when we look at it. So when we do this, we always want to go clockwise to denote which side of the triangle is the front face of the triangle. But if we take a look at, I know that we have some control over it. So in our domain shader, for instance, we're actually in our hull shader control point, or in our hull shader, we define that output topology is triangle CV, but this is like clockwise, but this is way earlier in the pipeline, and I don't think that matters much down here at all. Although I wonder, I remember running in this issue when I was creating icosahedron. Oh yeah, I can imagine one running into that problem. But I wonder, we're gonna try one thing. We're gonna try and do it counterclockwise. Because we actually calculate the normals for each point. Let me think. Yeah, we're calculating the normal for each point. The question is, the winding order, is it used separately for some optimized, I don't know, hardware culling? Let's try it out real quick. It's always good to test, so let's test and do it counterclockwise and see what we get, okay? So for this one then, we support counterclockwise. So then we do 01, then the new point, new point, then S 1201. Then S01. Then S12. It's 1200. Yeah. So we can see here that this is our full whatever we output. We can see it that the topology is weird, but on the back side the topology is perfect. The reason we're not getting this totally cold, I can't really answer for. That's honestly a bit weird. I wonder if call off, call front, back. Yeah. That's the problem we have with counterclockwise. Which is unfortunate. Always worth trying. I could have overseen something. So I guess we can look into this, or I can look into this way more down the line. I don't want to get stuck here for too long today. But I like this way of doing it. So just with an if, not with an if else. And I wonder why that's possible here, but not here. We should be able to do... And then... So we want to go this one, this one, this one, this one, this one, this one. Yeah, we should be able to do. Or let's see here. Yeah, and then we start this one at this one, and that's wrong, or is it? I want to try... So we start with this one, and then we always go to this one. Always, always, always. So... 01. And then we need to check. No, we don't, not yet. S1201. So this and always to this, and then we want to make a check. We either go down here or we go before we continue. But yeah. So here we do this check. So after we have visited this one, if we have an if statement, we go this one. So that is this one. And then we're done with that triangle. So if so, we do restart strip. And then we do S1201. And then we continue with S01. That we do outside. I think it's these. Start with this one, then we go to this one. But then we're counterclockwise again, so no. Are we? Here we are. It's just that, like, this extra we put here, it shouldn't be... Yeah, I don't think we can solve it in as nice of a way as this one, which is a little bit weird, but yeah. This triangle strip creation here, we can probably do some small improvements to that one eventually. But for now, this works just fine. So what I want to do now is, okay, we have this working. I'm probably gonna commit this one real quick. Let's see how it looks. we return the color and if we return this, the only thing I'm not that happy with currently is this right here, but it's not too bad. Oh, we have one issue related to this we're gonna take care of as well. This is not, it's not too pretty, but we're gonna solve one more issue before we commit, and that issue is return input.seam. We get a wrongful seam sometimes. Here we get a wrongful seam. So if we take a look at this one, and yeah, we get a wrongful seam when we are at the most amount or the least amount of subdivisions. So we get a wrongful seam when we have a subdivision of 0, and that's because I think it has to do with tessellation offset height, which we don't take into account here. So we do plus here. Tessellation offset. Do we get a negative value here? Maybe. The way we're gonna do it, I think, to solve this is we're gonna take tessellation offset based on height into account here. So we're gonna do calculate tessellation offset. Let's rename it like this. So we're gonna take this height in position center vs. We send in that one. World space camera position we don't need to send in. We send in step. Yes, we have everything. We're gonna calculate tessellation offset. Or what the hell? I'm thinking calculate tessellation. We might as well just do calculate tessellation. How? Because calculate tessellation exponent. I don't want to do, we don't need to do power 2 to the power of whatever we get here, and but we probably want to do the rounding. So anyway, we're gonna do float tessellation constant plane or tessellation offset is good. Tessellation offset plane, float tessellation offset height. So now we have tessellation offset plane and height. And what I want to do then is return. Do we want to do the... We can try without doing the round here, actually. So we're just gonna do... We want to clamp it as well. We don't want it to be... so we're gonna do return... min... max of 0 and tessellation amount minus tessellation offset plane minus tessellation offset height. So then we can just do all of this we can skip. And inside of this round, we just write calculate tessellation exponent, and we want to send in position center VS, camera position truncated VS, and step. We check tessellation offset plane here, however. That is true. So let's do it like this. Float tessellation exponent. Now we change this one to tessellation exponent, and we change this one to calculate tessellation exponent. Yeah, let's try this and see what we have. Fuck. Position center VS. Yeah, we want to rename this one position VS. That should be max, no matching to parameter, invalid subscript Y. We do step as a float here. Step. Let's do it as a float 2 then. Yeah, we can optimize this one later on as well. If we constrain our terrain to only be to always be a square, we can do some nice things here later on. Do I? Okay, this is not what we want to see, but so all of this gets marked as a seam. For some reason. So what happens if these are the same? Then we don't want to do it. Because now we truncate it to 0. So this one could be 0 and this one could be 0, which would mean... Is that really the error though? So for the one that is very interesting, topology. Let's see. Yeah, this issue still doesn't. If we tessellate 0, we don't have seams anymore, so that's good. But this one. So why the hell does every point here gets marked as? That's very weird. For it to be marked as a seam, so for this one, we get a high. Yeah, so this one is higher than its neighbors. Okay, I might know what we're doing wrong. If we... Okay, go back, looks good, looks good, looks good. That looks great as well. Huh. Okay, there we have it, I think. It's fucking great. I want to try... I want to get the height here. Let's see how it looks. Then if we zoom out, we're gonna see we have some edges here to solve as well, but that's okay. Normal calculations gets fucked when we have when we don't have that many vertices. This one we're gonna have to fix. This is what makes me want to go with... So either we're gonna have to calculate the normals in the fragment shader, or which is gonna be quite costly, or we do a pre-calculation pass of the normal. So, which I think what we are finally where we're gonna end up. So we're gonna calculate the normals still on the GPU, but we do it in a compute shader, and we do it anytime the terrain changes. Because apart from that, I think it looks pretty good. I want to try and see what kind of result we have if we do the normal calculations in the fragment shader. Just when we pop it like this. Double check. I think we can do some dose up viral air. Yeah, it's pretty nice. I think we can do some. I mean, this looks extremely cool. I think we're gonna do some subsampling as well on the MIP map later on. We'll see. And then again, we do the popping solution right now. We have every information to not do the popping solution. We're gonna try that one soon. I think the popping is most visible here. Right. If we did... let me just commit this first, and then we're gonna see if we can get some... we're gonna try doing the normals in the fragment shader. And then we're gonna try and animate the popping. I think that might look very nice. Actually, we can go even more. But. Okay, let's commit this. Just gonna clean it up real quick first. We're gonna leave test, offset scale, tessellation distance bounds, calculate new points, split quads. Max height and everything else good. Normal VS. We don't need to send in this one. It depends on how we calculate our normals later on. We could do it by world space position. Normal VS. I think it's normal VS we use most of the time, so... But... It's also nice to have it in tangent space. We'll see. Let's keep this one for now. I don't think we need to use these at all. You direct interpolated point 19 times. Yeah, this one is different. Let's remove interpolated point. And here we still want it. Not here though. Now what more do we have? View direction, yes. Tessellation direction I don't think we use. Seam we use. But let's put this one here and name it text chord 2. Geometry shader output we don't use. I'm doing a little bit of a hack here. I don't know how bad this is, but we pretty much let our domain shader and geometry shader return the same struct. I don't think that's too... No, I think it's okay. I think it's okay. Okay, there we have it. A very nice tessellation solution. Ready? Yo, what's up, DevSpires? Happy Friday. And thank you for the raid, appreciate it. As always. And so now when we have this finished product here, or finished shader, I don't think we're that far off by being able to put it in its own file. We can definitely do that, but before we do that, I want to commit it and we want to experiment with the animated interpolation and calculating the normals in the fragment shader. I think we will get a way better result. The only reason I would like to offload the normal, not doing the normal calculations in the fragment shader eventually, is because doing it in the fragment shader is costly, extremely costly. So for each fragment rendered in the terrain, we're gonna do 4 texture samples, and it hurts. But okay, let's double check this so everything works after our cleanup, and then we can commit it, and then we can experiment with it. Also, this one right here, this edge right here, when we decimate it, we get a quite a big height difference, right? I think it starts, this is still fine. Here it starts to look a little bit weirder. And yeah, so no matter how we animate this, we can probably animate this okay, but I'm the most worried about this one. So let's say that we look at this peak from a very far away distance. We're pretty much gonna have a mountain growing up from nothing here. We can solve this in a few different ways. The original mesh can definitely be a little bit higher resolution. So this would be fine. We can animate it. This one is the worst one, I would say. normals as well. I'm pretty sure we want to downsample here. If we don't split our quads with the current solution, we get visible seams. So not splitting them is not a solution anymore. Okay. Let me just commit this real quick. I want to add materials. Okay. So we're gonna start by calculating the normal here. And I wonder how it will look if we just do load 3 normal vs is equal to this. We need UV step. We need not final point UV, but input.uv, and that's all we need. Do we set UVs here? We set UV here. That's good. We set UV here, but we don't do it for final point. And UV step we don't have. We calculate UV step like this. We need UV scale. Not UV offset. Now we have UV step, we have a normal here. Let's use this one. And we restart it to get the correct data. Let's see what we have. Yeah. That's much better. Now the popping is a bit more visible. Although I wonder... Honestly, we can probably fix... Yeah, we can add a constraint for... I mean, rendering a terrain, what do we get? Worst case scenario, we render 10 meters using 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. So that's 1 vertex per meter. You can't... I mean... It's gonna look rough from a far distance. I just want to check if we... terrain like this. This is the interpolated points. We're gonna experiment with these. What's up, Pineapple, by the way? Topography is always rough. Yeah, I've learned that during the past couple of weeks. Maybe it could look better if you had the vertex reduction preserve the highest and lowest verts in a place and not just reduce grid resolution. Yeah, so the problem with this peak is... yeah, we can definitely do something like this, I reckon. So we have a slope here, we have a peak here, and when we render it from extremely far away, we get this point before the peak and we get the point after the peak, which means that the full peak is pretty much ignored. Like, this is definitely something we would like to solve, but the question is also, will this be a problem with proper data? Like, do we really want to decimate the mesh this much? If we would add a lower bound, that is maybe this. It could be okay. We could also step down a bit in the MIPS, but then we would get a mean value. I just don't want to have peaks extremely far away from the camera appearing like this. It's hard. Or it's also, let's see here. You could also constrain it based on how much gradient, so the difference between lowest and highest point for one quad. Yeah, I've no doubt that we can solve this eventually. First of all, I want to try the interpolation solution. So instead of having the new vertices pop in like this, we are gonna interpolate them, although change it like this. Although I'm a little bit worried about these seams here. If we do interpolate points, yeah, if it's a seam, we just want to interpolate this point right here, I think. Or actually, no. Okay, I get it, I get it. I think. Let's reduce this one a bit. Take a look at what's happening here. So all the new points, we interpolate all the new points. See here, test 0. Now we interpolate all the new points. Except for this one, actually. 0. Okay, let's see. Yeah, the new points for this one are this one and this one. So we interpolate this point and this point for this one and this one. And for this one, we also need to make sure that this one is a new point, this one is a new point for this one. Okay, so the problem is if we have a seam right, don't want to interpolate this one. If it's a seam, so let's see here. In this one is marked as seam, this one is marked as seam. So all of these gets marked as seams. This one we don't want to interpolate. This one we do want to interpolate. Okay. But one sec, no, we don't care about that. If we want to interpolate or not, it is entirely decided by position to camera. This point, all of these points has the same length to the camera. So we're gonna have to calculate length for a lot of vertices, but I think that's okay. So basically, when we do lerp domain shader output, this T here is gonna be not this T, but what am I on about? Let's see. Yeah, so we create a interpolated point and a final point. I think here we can probably optimize it a bit as well. We don't need to create two of these points. They share a lot of the same a lot of the same calculations. We're gonna, I think we can optimize this one right here, but position VS and normal VS, even though we don't use this one anymore, those two are the only things we really care about when it comes to T. Seam they share, color they share, UV they share, view direction they don't share, but it's based on position. Normal VS they don't share, position CS they don't share, but it's based on position. So we pretty much just need to interpolate the position and then we're done. We send down UV step here. So what we want to send down as well is We're gonna take position in X. Will that be weird? Okay, so we're gonna try and clean this one up, which will mean that we don't need this one either, I don't think. So domain shader output, create point from E1, E2, float UV step. Then we're gonna have a float T here. And we're gonna start by calculating float 3 interpolated, actually position interpolated VS is equal to lerp V1 position VS D2 position VS and 0.5. Then we do float 3 position final VS is equal to it's equal to position interpolated VS, but then we do position final VS dot Y is equal to this. And we do float 3 normal interpolated VS is equal to this one, and then we do float 3 normal final VS. That is equal to this one. Although we use final point UV here, which is this one. So we're gonna do main shader output. Then we're gonna set output.uv is equal to this, and then we can use output UV here and output UV here. That's the only thing we need. But we can also seam and color we can create here. So now we have these 3, and then we have these 4, which are all going to be quite different. So finally we do output dot it is position world space we want to calculate first. So we're going to do position VS is equal to lerp position interpolated position final and then T. But I'm a little bit worried about this T. We might calculate this one in here as well. Yeah, we're gonna calculate t in here if we don't take y into account. But then we calculate the position world space. So position in clip space is just equal to transform. Output normal vs. We want to do the exact same thing we do here, but we want to do normal interpolated, normal final. Then we have view direction as well, which is based on position. So output position vs here. Something like that. So instead of doing this and this, we just do this. Let's see if we get the same result. Oh yeah, we need to send in the t as well. Let's skip sending it in and do load t is equal to test. Yeah, and then we want to return output as well. I'm gonna restart it so we get some height. If we do test 1, we get final point and we're fucked. Okay, what did I mess up here? Is it just... we have a wrongful seam here. So this one. Previously we did... interpolated point seam p1.seam and p2.seam. Yeah. And then we set final point to interpolated point.seam. So if this is true, this is true. And then we do a lerp. So... Well, did I manage to screw this one up? This one gets marked as a seam when it shouldn't. And this one as well, actually. Hmm. In what world does this make sense? We do the exact same thing. We didn't have this one previously, did we? No, we didn't. Look at this. Why is this issue back this time around? It makes no sense. We have a marked seam here. What the fuck? Tessellation exponent. Yeah, we only get it on this one. Okay, it's dependent on this one right here. So if it's 6, we don't have a problem. Tessellation amount POW. This is the only place we use it. Oh, is it because we don't round it here? Is it really? Might be, might be, might be. But we don't round it here either, so... Can we get a negative value here? Abs, this one is always positive. Always positive. Lure. If this one is 0 and this one is 0, we get false. That is how we want it. Definitely has to do with the rounding. If we do full numbers, 1, 2, 3, 4, 5, 6. Full numbers, it works. This one we floor. Okay. Tessellation amount POW. I don't think I want to add any extra calculations here. Instead, it would be better to just limit shader input to integer values. Do we just define it as an integer? It's integer. Oops. Range. Oh, that's not the one I want to change. Tessellation amount POW. Yeah, there we go. Okay, great. So now we can continue. Although, might have quit that one too early. How to limit. Okay. In slider. But I don't think we can use this one, or can we? Sure, we can use this one in a shader here. Ah, fuck it, we can keep it like this. Okay, so back to this one, create point from. The T here is gonna carry most of the burden to get this looking nice. And we basically want to calculate the distance from the point in question to the camera, and then we do a inverse lerp on that. Or not really. Not this time around. Or maybe. Step. We're gonna have to do some calculations related to mesh resolution. Or rather, we want to calculate... Yeah, we want to calculate step here as well. That's the inverse slurp we want to base it on. So basically, let's see if we can do some nice drawing for this. If we have a point, okay, we have one of our quads. We have a point here, and we have the camera right about here. We want to base I don't know in this. Okay, so maybe the camera truncates to this position here. It's gonna be... Yeah. We calculate the distance to the point. If the distance is within, or if the distance is between okay, if the camera is located on this one, we want to do some tessellation then. Basically, we want to do inverse lerp x y distance. The hardest part is figuring out what we want these to be. We do some camera position truncation. Would love to avoid doing that again in the geometry shader. And this is going to be equal to our t. So it's basically when do we want to use the final point position, when do we want to use the interpolated point position, and inside of which range do we want to interpolate between them. It's basically based on I don't want to reintroduce the truncated point here. So my question then is it possible without reintroducing the truncated point? If the camera position is less than this, maybe that's what we want to base it on. The diagonal length of our quads. So if we call this one Q, then I wonder if we want to have Q to Q. Or maybe try first by doing it on this. What do I want to call that one? And let's call it L. L to L. Yeah, let's try that. So we have to calculate the step again. Where do we have it? Step, step, step. We're just gonna do it like this. So down in this one we do load step is equal to this, and T is equal to if we want to calculate this one after we have position and normal, so before we do this. T is equal to inverse lerp step actually want to do 2 times step here, step here. We do length, camera, world space, camera position, xz minus position interpolated vs.xz. And then we use t. Oopa. Yes, because we want to do inverse lerp 01. I hope. Okay, we get a little bit of a mismatch here. That's not good. Yeah, it definitely looks opposite to cozy right now. This one is... We don't get any interpolation at all. Yeah, of course, of course. This definitely not. Do we need a truncated position? Yeah. No, we definitely don't want to work with the truncated position, I don't think. Oh, this is weird. So, if it's located here, this one has tessellation X. The points closest to the camera, we want to have final point. These should be interpolated distance. how close we are to them should be that we define ourselves. So the lower bound, this one, go with 1 meter. But yeah, we pretty much want to figure out how close are we to do... How close is this point to being tessellated once more? Or once... No, how close is this point to being tessellated one less time? And one more time. So we want to take... Which makes me think that we want to calculate tessellation exponent again with the truncated camera position. And divide it by a tessellation exponent with the normal camera position. Mm-hmm. Would that work? If the camera were to be positioned here, length to from the point to the camera divided by length from the point to the truncated camera position. So we have length and length truncated, and we do length divided by length truncated. And that's our T. Or oh, if the camera is here, truncated. this point, for instance, we get I want to see what that gives at least. T. Hmm? Unexpected. Okay, what am I missing? Hmm. Yeah, we don't do this for the original points. We might want to do this for the original points as well. Oh, that is gonna suck. Hmm. Do we really need to do it for the original points? No, we don't want to do it for the original points, I don't think. But this doesn't look too good. Okay. What the hell do we have here? Divided by 0, probably. Okay, this is a little bit more complicated than I initially thought. This one not being marked as an interpolated point. That's not good. Or it's for, yeah, it's for this one. We need to mark this one. If it's a seam, this one, don't want to mark this one. Because it existed in the previous one, did it? Yeah, okay, I get it. We have to handle these a little bit differently. Okay, other than this, it works fine, and that is when we have a seam. But it's one of the original, is it? No, it's not. It's not one of the original. So when we split, this one, if it's a seam, we want to do t is equal to 1.0. It's equal to 1.0 if output dot seam we need to send in something extra here. Ooh. Create point from. This one is seam, this one is seam, this one is seam, but we want this one to not be marked, but this one to be marked. This one we can double check. These are actually always new. These are... one gets marked as new. But if it's a seam, we don't want this one as new, but we do want this one as a new. This is not a seam, okay. Although I wonder... Okay, what I'm wondering is, do we have enough information currently to properly flag these, or do we need to add some extra information? Would like to avoid the latter. We know that it's a seam. But so is this one. So we're gonna have to send in this. Actually, if it's a seam, okay, if it's a seam, we send in. How would that work? If it's a seam, let's do it like this. Is equal to output dot seam. Okay, if it's not a seam, we always return 1.0. If it is a seam, we're gonna have to return, do some extra calculations. to identify this one and this one. Or we just want to identify this one, right? We do Tool Force New. Or actually, we do it like this here. Skip it. Extra seam vertex. Then we do create from point, create from point. Point 0. Zero. So the only thing we have done now is that true? Actually, it's not, I reckon. Let's see. No. So for this one, this vertex existed already. Center vertex. So this one shouldn't be marked either. Huh. Is it always the center vertices? Then we have this one. Yeah, okay. Do new point. So center vertices are never new points. I don't think that's S1, 2. New point, new point. S1, 2, O, never. Okay, something like this, then we just have to fix the seams as well. And with new points sent in, how would we handle these? Yeah, we already check seam here, so we can do this one is never new point. Never new point. Or actually, one sec. Oh, fuck, they are always new points. Yeah, okay, so if this one is new, then S01 is not new. Which means that we're gonna have to do something ugly like this. I don't like that. These are always new points. These are new points if we're gonna do... Unless it's a seam. So we can multiply by 1 minus seam. We want to do it for S01 and S2 0. S01 and S2 0, these two. So 1 minus be careful here. We can't base it on these seams. Actually, yeah, it's S20. If it's marked as a seam. What an annoying problem to have. Feels like there's always one point or one set of points that fight against us. Let's see. This one should be marked as the original ones are never new. This one is never new. These ones are always new unless we have this sort of subdivision going on. We calculate this one first, so we don't know at that point if these exist. But S20. And we can't send in, we're gonna have to send it in like this. It's a new point if, no, it's an old point if 1.0 minus 01.seam and 02.seam. This is not where we want to do it. This one should always be 0. S01, this one. And we do the same for this one. I think. Looks to be alright, but looks like shit. At least in this render, but it looks... Okay, I think that's good. Needs to work here as well. Okay, so this is the... This is pretty much just a float. That is a binary float that is either 0 or 1. If it's 1, we're gonna interpolate. If it's 0, we don't interpolate. So whatever interpolation we calculate here, we are gonna multiply it with new point. Okay, so back to the interpolation problem. This is... shouldn't be that hard. Camera length divided by, let's do new point multiplied by whatever we had here. Which could lead to a division by 0 if I don't. Yeah, we want to saturate this result as well. Saturate. Yeah, that is true. We're gonna get some if we use the truncated camera position, we're always gonna get some popping. We want a better fade here. So what the hell do we want to base it on? It's basically all of the white ones should have the same. All of the white marked vertices should have the same interpolation constant. And it's basically how close we are to tessellating it one more time. Oh fuck, I'm lying there. We should definitely have, it should definitely be darker towards or closer to the camera. But it's very important that we So it's pretty much like this. If we take this white point here, if we move closer to it, it's going to become darker and darker and darker. Flip. We do position center here. Which is... Could do a solution that uses this one, but it wouldn't be as dynamic as I would have hoped. It's basically about... So for this one here, we want to fade from 1 to 0. And then we want to do the same here, 1 to 0. Or that's not entirely true either. thing is that we do tessellate the full quad instantly. Yeah, we probably need to figure out, yeah, how close is a quad to being tessellated again. So we need a new number there. And we can do something with that, I think. Yeah, definitely. So the question is... the truncation of the camera screws this up a bit, I would say. Okay, yeah, we definitely want it based on... If we would have a float for each subquad that explains how close it is to being tessellated once more, or once less. We can use that one, but then we're gonna animate everything at once. I want to animate each point individually. We're gonna have to multiply it by one more. Shouldn't we do... What does... Truncated to step. Length to between world space, camera pulse, and I just care about XZ and camera position truncated. Length, no max. Yeah. But I reckon we want to use... Okay, if we take... Oh, okay, maybe this. If we take the distance from the point to the camera... Do we care about truncated? If we take the distance to the camera from the between the point and the camera and the modulus step, and then we take max of x and z. Weird. Let's try it. So if we do t, position, interpolated vs, there. What do we get from this? Really? Huh. Okay, this is the closest yet. But it's weird that we don't interpolate at all, interpolate more. It's not perfect. Yeah, then we need to compare this to the actual tessellation we have. We never get 0 though. We need to define. I really need to find exactly what we would want. It should pretty much just be a sphere around the camera, wherever we are located. Much like we have now. Within that sphere, it should be tessellated once more. Okay. Does that make sense? No. It's pretty much, if the camera is located inside the square, we can, yeah, if it's located inside the square, we do interpolate 0. Or interpolate 1, I mean. So if the camera is located here, all of these will be interpolated max amount. What am I getting at here? Distance to the truncated, or distance between... Oh, what's up, Skyfer? What am I trying to achieve? We're trying to dynamically change the height of the points. Where each point has pretty much a interpolated position and a final position. The closer we get to them, the more towards its final position it should be. Actually, I think it's pretty... It's 100% a truncated function. So we want to calculate distance from the camera position. This is needed for... we want to reduce popping on the tessellation. Later on we're going to put this in its own shader file and use it both for water, terrain, snow, all of it. It's just a visual improvement pretty much to everything. If we have a point here, or actually if the camera is located here, we have the distance to the truncated one. So then we know this full one. How far away are we from? It's not entirely true. This problem is it builds on a simple principle, but based on how we tessellate the subquads, it complicates it. Okay, if we take the distance from whatever point we're rendering, the distance between that point and the camera, then we take max out of Z and X. We care about X and Z. Need to double check this. Tessellation exponent, step, BS. Probably just want to do XZ here as well, right? Okay. So I don't want to care about Y right now, so we're gonna take height here and remove it. So we only tessellate based on the distance in the XZ plane. If the camera is located here or here, thinking that okay, we can't do it individually. So we're gonna have to do it per quad, because if we have the camera here and we move closer to this one, at some point we would pop into this one. Fuck, what a complicated problem. Yeah, we pretty much jump around on these points. When we make such a jump, have I screwed it up for myself by including these points right here? If we were just jumping between these points, so including these points might have screwed it up. Because if we only have these points, then when we get to here, we're gonna tessellate it once more. It's gonna get screwed up. Yeah, the truncation definitely doesn't help. look at this. If this is our visual radius, where would the camera be located? Roughly around here, I think. It's always a question of, given one quad, how close is this quad to being decimated or tessellated? Then we can interpolate based on that. But we always have the interpolated point and the final point. Do we ever use the final point? Yeah, I think we always need to tessellate once more than the quad we're actually in. Otherwise we can't do this nice fading right. So located at any of these positions, this one will be tessellated the most amount of times. So we can't really play around with the animation of them. Okay, so so if this one, if the camera is positioned here, we could do tessellate this or these the maximum amount of times. For this one we don't animate tessellation change. For this one, these ones we do, for these ones as well. And we animate how close are they to being tessellated once more. And if we do it like this, we don't care about the middle points. So if the camera is here, we tessellate both of these. We tessellate all of these the maximum amount of times. This one we don't interpolate at all, or this one we only interpolate at. This one, if it's located here, this one is like fully interpolated. Something like that. Okay. It's something like that we have to do. we should be able to base it on camera distance. But so that would be we would need to do calculate tessellation exponent. Tessellation offset plane -1. Wait, that's the same thing, is it? So we would need to do step. 2 times step. I don't want to do 4 times step. It's just the first one we want to. Does this make any... I think it does. So pretty much the neighboring quads here would be tessellated as many times as this one. For this one, in XZ, we don't interpolate these points at all. We keep them at their final point. For these, we interpolate based on camera distance. This is also based on camera distance. Would that solve it? Just need to be able to handle the jump. Hmm. What am I on about? This one right here, we animate more and more and more, and then when we get to, or so for this one, we interpolate the points more and more and more, and then when we get closer to it, so right about here, the interpolation would be towards the final point would be 1. And then when we flip over here, it should be 0 again. And move bigger and bigger and bigger. So when we move away from this one, we should be moving towards the interpolated point, and right about here. Okay. Should be able to do, but yeah, it should work the same with this one. So so when the camera is here, okay. One, 0. So if we have the truncated camera here, and we have the camera here, so we have a small difference, bigger, and right about here we have one that is step size. So when we move all over here, it gets truncated to here. We have a big distance again. We have a big distance again. But the distance to the point... When the camera starts to get further away, it 100% needs to be synced with the camera truncation flip. That feels hard to do. We need to calculate the center point. Do we need to know the center point? Furthest away from the center point we can be is... So if we have the camera here and we're located here, then we have 2 times step. Two times step. So if the camera is located here, we still tessellate this point the most, and it's 2 times step to the power of 2 plus 2 times step to the power of 2 and then square root. If the distance is within that, then we know that it's tessellated the most. That's the furthest away from a point we can be with it still being tessellated. But then if we move to here, That's just half that distance. Then this point is still within that bounds, but we don't tessellate it that much. Finding the upper and lower bounds and how to handle this one. Extremely tricky. If we had the center point, or if we send that down, it would be way easier, but we wouldn't be getting a... We wouldn't be getting... as of a dynamic result as I want. But honestly, it feels like the best approach would be to work with two different interpolation values. One is the camera located within the quad? If so, do per vertex tessellation. If the camera is located outside of the quad, do per quad interpolation. So then when we get about here, located in it. It's just a question of, or the distance from the camera to the quad, being inside the quad. Because I guess, so when we're located here, or right about here, we can start doing inside quad tessellation here. Yeah, we can start by doing that. I think that's the easiest point. So basically, we only do tessellation when the tessellation interpolation when the camera is outside initially. So this quad here, the closer we get, we start a little bit earlier. So we're gonna have to calculate that. We're gonna calculate the constant during tessellation, which we then send onwards, which I'm not that big of a fan of, but the center point. Yeah, we do center point. Yeah, if we send the center point, then we can calculate how close or far away it is from being tessellated once more. I reckon. One, 0. Yeah, now we need to take height into account as well. Fucking hell. Actually, the best would be... Can't wait to use this topology for my terrain instead. I think the digging is gonna look great. But I really want to make this work first. Yeah, it's all about finding the lower bound in distance, finding the upper bound in distance. I'm gonna have to think about this one. We did have some nice progress in the beginning of the stream, but then this problem, yeah, this one is gonna be difficult to solve. I can see I'm gonna try and theorize a solution this weekend and get back on Monday prepared, because I gotta run now. Really wish Tessellation were in place for the new week, but yeah, whatever. Thank you so much for watching, sticking with me, appreciate it. Have a great rest of the day, and have a great weekend. Peace.